you have to make one new unit system. Tools. Now then create review units. Now in this one create a new unit. This is the already installed units inside. So anyhow you have to change just a little bit here and there. So you can select any of that one. Now new unit file name which you are creating. Now in this one it will show. First these points are taken from that SI units whichever it has. Now suppose if you want to change in that, suppose this length that's in centimeter, you want to change it to millimeter. Now in this, suppose this will be given if you're now you're joining these units now it will be there. Just showing you from basics. Suppose this force pressure, you want to change it to Newton. Okay, Newton per square centimeter. Last display model is Newton per square. Like this you can change it. And save. Now in order to use that units, configure setup. Go to database create. Now here see this was the default when you open first this one. Now you want that. Just now we created this one. Save. Now when we open a new file, the units which you change. Now this is the piping input. Suppose whenever you are opening again this one, when you select open and select that file, after that you need to press this piping input. This will come up. Now this one. This is just now, and for doing procedure, that's an ISO of the pipe. This is the ISO of pipe. This pipe data pro software, it will help us in taking the standard units. So for first one, this particular symbol is for a nozzle. And this line is a 4-inch line. So for this we need a 4-inch nozzle. You have to go to pipe data pro. From here, nozzle is a perforated component. So the flange, we need a flange. Okay. This one is a flange. 6 Now we need a 4-inch flange. And suppose if you want a class for the flange, this is the dimensions and weight for a 4-inch flange according to SME B16.5. That's the standard for. Now we need to put a flange here. So what is the length of flange? Is 77. These are our directions. First one was Y direction, 77 direction, and in this one, say, under rigid flanges, any gate valves, ball valves, any component, the components which are connected to the pipe, that will be under rigid. Bends are elbows and all. T, one taking branch from a pipe. T is reducer 40 degrees in the diameter of pipe, decreasing or increasing. Rigid. First we need to diameter 4 inch. Schedule means the thickness of pipe. Shear considering corrosion allowance. All these things, corrosion allowance and what is it, material, will get from PMS. So you want PMS. Piping materials. This line which we are doing is just for practice, so it's not from any of the real plants. So I'm just showing you how to take it. Suppose suppose that line is this one. I want to say line number 104. So it will from here this pressure and temperature will be given. Will enter here and the schedule number. See this one. The specification spec of this pipeline is this pipe is this particular pipe was A1, which I'm showing you. See piping spec is A1. Insert you get piping A1. From here you'll get corrosion allowance and this mill. What is the material you need to use? ASTM-A. Now we are putting here just for dummy one. ASTM-A 106. Corrosion allowance. Fluid density. Suppose it's some water flowing inside. So fluid density for water is 1000 kg per meter. So now we are putting in this centimeter, kg per centimeter. So it's 0.101. You need to enter the temperature and pressure for that. See, in PMS, you will get the corrosion allowance. What is the material used for that pipe? And all materials schedule number. Suppose that's a 4-inch line. See, standard 4-inch line. The schedule number for the schedule. That is 80. From line list, you will get what is the temperature and pressure for that. Hello? From here you will get the temperature and pressure. It's not the exact one, I'm just showing you. Now when you select rigid, it will ask for the weight of that particular component, and that you need to take from this one pipe data pro software is there. Right? This is not there in most companies. You use this one. It will be there. Otherwise, you have to refer that particular ASME B16.5. Here weight is concerned. Now this is done. Now you have to press continue. Or the shortcut for this is Alt C. After some time, after some 10-15 minutes, you need to save it. One particular option is there for automatic saving, but I don't know what is there. Now moving on to next. From here, from face of the nozzle, from face of the flange to this point, the length is 228. But we have taken the length of this flange as 77. So we need to subtract it from that. And in this one, whenever you enter a value into scissor for elbow, it will take directly from center to center. You don't need to put, suppose elbow is starting from here to here. You don't need to put till here the value, then the length of elbow. It will take directly from this center to wherever you take. So for Yes. So we have entered into X. Yeah, it's going in wider. Just then again save and continue. Now it's going in y direction. Now the value is 151 for the pipe. And at the end of that pipe, we have a bend. Elbow. Bend. Now when you move to this point, continue. 1200 and again a bend. Now when you enter the value of 1200 here, and it's in Z direction. So 1200 and at the end of that pipe is a bend. See, when in the last step we put bend here, okay, here. Now when we enter for the next length, we'll take a bend here and start. See, now the pipe is from here till this center of this T 735. Yeah, because we need to put a T there. We can directly go to here, but we need a T here. That's why at this 735, see, T is one of the components which branch connection. Elbow is for bending a pipe, 90-degree elbow, 45 degree. A T is one which takes, suppose a pipe is going now, you need to take a third pipe from that. A T. Similar to this one. So, okay, he's taking a pipe from here again. So, at 735, then we need a T. That's in minus y direction. Y is about going upside and down. So last time I did put it. Right. Yes, save and continue. This one. Right, yeah. Right. Control S is for saving this file. This Alt C is for continuing the pipe. Saving this pipe here, continue. Means it won't be saved in the file, you need to save it again. Just for saving this pipe. Now 735. Yeah. 735 in minus y direction. So minus 735. And at the end of that pipe we have a T. So you need to select a T. And T will be a 3 welding. T is a 3 welding. Now continue. First we'll draw this total, then we'll come to this drawing this. Now from the center of this T to the elbow, we have again 1000 in. So minus 1000. There is a bend at that point. And if you want this software to show you T there is one option for showing that. But particular part now it's not showing the T there. I don't know why it's not, but it will come here. 228 minus this, it's taking from this center of this elbow in the flange face, so it is showing 228. Again we need to minus that 77 and that 5 in that 5, so it's in which direction? Minus x direction, so minus 151 length of that pipe. And whenever at the end of the pipe some rigid component is attached, no need to put anything in rigid or bent. Pipe came there. Now that flange you need to put there. Minus 77 is the dimension for that flange. This is how we found the pipe rigid. The weight was 7.11. That flange came. You see after this flange there is a gate valve. gate valve, suppose it's an activation valve, means it will stop. Now we need to see what are the dimensions for the gate valve and what's the weight of the gate valve. Flange valves. We need a 4-inch gate valve. This right face raised face and 150. The class of that one. 4-inch. You see, the length is same because this drawing was drawn according to the dimensions only. Length will be same. For this flange, the length was not given. In order to cross check, you can see this 229 the length of gate valve. Here also the length of gate valve is 229 and the weight is 52 kgs. So, yeah, 5 beta pro will give you the dimensions of that particular component, pipe, whatever that it is, according to the whatever standard you want, SME standard or ASTM standard or BS British standard. So now in this one, minus 229 because it's going in minus x direct. Minus 229. Again, a gate valve is a rigid component and the weight is now also 52. Now again we have a flange. Sometimes what will happen is the software will crash and crash all over the because it's better if you save after some time. Otherwise it will last up. There is a point for auto save. There is an option for this auto save. After some the matlab if is put there 15 after 15 minutes it will show on the on the screen that 15 minutes have passed and now after this gate valve, sorry, after this flange there is a reducer. Means it will reduce the size of this line from 4 inch, see it's written in 4 cross 3. Means this side of the reducer is 4 inch, this side is 3 inch, so it will reduce. And here it's showing a 12 mm offset. Offset means it's an eccentric reducer. Concentric reducer means what you say, this side 3 inch diameter, 3 inch dia and 4 inch dia. The center will be at the same point. Suppose it's an eccentric one. This so what you say, axis of this 3 inch diameter and 4 inch diameter will be varying. That is an that with an offset of 12. Show you. See, this is a drawing which is given to us, and we are just putting it in the Caesar to draw. Exact reason for this is known by the process people. They decided it to reduce the diameter of that, and it's an example. So it's showing you all the components. 4 cross 3 inch offset. Now we need to see exactly where what are the dimensions for that. What welded. To take a concentrate to see this is a suppose 4 cross this 24 cross 16 this one this particular. So here the centers are matching. The axis of both the centers. This is a concentric one. Suppose if you take an eccentric reducer, we need a 4 cross 3 eccentric reducer. 4 3. See, that was the center for this is the total nozzle. That was the center for this 4 inch there. And here it was the center for 3 inch. That is varying with the axis of these two centers are varying with the terms of length. Okay. Now the length for this reducer is 1. Here it is given reducer plus flange the dimension. Now we are drawing a reducer. So it's in minus x direction and the dimension is minus 1 or 2. Minus 1 0 2. And here you need to check a reducer. And the second diameter was 3 inch. The thickness is same, schedule number 80. Alpha, I don't know what it is, but it is 14.
Also in material stability.
The piping material stages are given. PMS A1, and we are using a 4. Here PMS for is for pipes or
For material, for alter material what which type of material and which type of
have you seen it?
I think should be given.
Actually, I don't know where it will be given. Because Monday you can. Even I want to ask what is this alpha in our reducer 4 cross 3. Now you see when we are entering this one is coming as a concentric one. You need an eccentric that will then offset of 12. So you need to put here 12. What is the thing is this one eccentric is coming at the top. Eccentric the flat side up. But for what to say a line passing horizontal. This one is this actually this is the drawing for a control station. This thing is called as a control station. So in this one you can see here it's a flat side down. Flat side down. So in order to make this flat side down, put here minus 12. Minus 12. Okay. Now save and continue. Now we have a flange of 3 inch because we reduced it. Now for seeing the flange size of 3 inch, flange 3 inch. The dimension for this, the length for this is 70, and the weight is 4.97. After that, we again have a gate valve. This will be of 3 inch. Last time here we have taken 44. First we need to see what are the dimensions for that. Flange valves 3 inch, so not 3, and the weight is 34.
It's below wall. I think it's below wall. It's 241. How much is its length? 241. It's below wall. What below wall? 3 inch and plus 3 inch. 241.
Those are globe wall. So we need a 3 inch globe wall of, so the size is length is 241 and the weight is, and in Caesar it will show all valves same, but in real globe valve and gate valve all valves look different. In Caesar actually it will show all valves just like this. So now 241 length and 42 kg.
It's given in our pipeline. This is a low voltage.
See, this one is just for analyzing the pipe, and in the pipe we need not, for analysis we need not know what kind of valve it is. We just need to know the weight of that valve. So is that what it will be acting on this one, dimension of this valve and weight of that valve. So this is not for supplying to the vent, on the site for construction and all. This is just for knowing what are the weights acting on that. Now we have a gate valve, grow valve in minus x direction, and the dimension is 241, and the weight is minus 241. Again, it's a valve, it's a rigid one, and the weight was 42. Continue. After this, again a flange, then expander. Expander is the same as reducer, but in this reducer will reduce the size of pipe, expander will increase. Now we need a gate valve here. Oh, sorry, flange here for the range. Flange, range flange 70, 4.97. 70, 4.9. After this, there is an expander for cross thing. Again, that is also this one. See, reducer and expander both look same. Just the thing is, if you want to reduce the pipe, you'll attach the bigger one here, increasing here. So this reducer or expander will come same. This depends on the use you are using it. Suppose if you are using it for increasing the size, you tell it expander. If it's used for reducing, you tell it reducer. So here it won't give you expander. It is reducer. Then this length is 1 or 2. Minus 1, 0, 2. Here again you need to check reducer only. But here it was 3 diameter, the range. Suppose if you want to reduce the diameter, you put it 2 inch. Now you want to increase diameter, put here 4 inch. Schedule again it will be same. See now I show. See again here it's a concentric one with nothing. Just if you want to put 12. Actually I came at this node. Which were the yellow highlighted one. At that point the action is happening. So we need not change previous element. Now we need to move to that element. Now it's at that reducer, particular reducer. It's at that particular reducer. Here we put 12. That side down. 7. Now again we have a 152 at that appendage. There at that point. 487 with subtracting this flange value. Flange, this is a 4 inch flange, so length of that was 77. So 410. That is in positive phi direction. Here and there is flange, there is a rigid component, so we need not pick any of these options here. Okay. Now we need a flange here. 77 rigid 7.1. After that again I get 229. And rigid component and the weight I think now we have increased the size of that center plate. Again a flange. Now you See, from the flange face to the T point, it is given 281. You need to subtract the flange face 81 minus 204. Now put here 204, and at the end of that is a T. So we need to take this one T, and that's a trivial formula. Then 2033. 2033. There is a bend at that point. Then 8115 minus 715 minus 77 8038 minus x. There is a plan, so no need. Continue. Now flange was of 4 inch. So 4-inch flange size is minus 77, and the weight is 7.11. Then there is again one more flange. You see, these two flanges are connected together. This is called as a breakup flange. These two combination. Why this will be used is, suppose there is some maintenance work you need to do in this line. So you can't separate it from anywhere here. You can't take out this one. So in order to separate this line, a breakup flange is needed. Whenever there is a maintenance, here you will take out this and you put a bland flange here. Bland flange means it will just a kind of plate that will be attached. Suppose if you need this one out, we'll take this one out. Only this flange will be there. With this flange, a bland flange will be attached, and then this whatever the input or output going from there, it will stop. So another flange is there here. That will be again of 77 minus exact. 1 1. Two flanges. After that, we have a 226 length, including the flange. Equal to 6 minus 5. At the end, there is a bend. Then 1304 going up. So positive y direction is showing 304. And at the end of that pipe, there is a bend. So bend. Then this line is of 17350. In z direction minus z direction. 730. Now we need a line here. T. We have already put this T here. Now we need to draw this line. So we need this point. Here we don't know where this point is. So we need that node. So for that node, there is an option. When you click here and put n, nodes will come. Or else you can click here also. And this show node. So that part you break up at here, that pipe at 50 node. So here from point, you see this 280 is the last point there. We have drawn this followed by node. So here that node is 280. Now the next node that will come is 290 or any other. So, but we need a pipe from here 50. Just remove this 280. Go to here 50. This thing let it be anything, right? Whatever is going on, let it continue. That length is 363 minus 77. 286. That's in minus x direction. 226. 286. Now it's showing that no pipe was there that time. Now the pipe is there. Now here also same. We need a blanch A12. Blanch. So draw the G1. Now we need a here get out of there minus 29. That was also it is blanch A12 blanch. Now we need a pipe from here to here. This node to this node. We need not calculate the length of all this. We just see the node number of last node number of this 320, and here we wake up that pipe again. Yeah. So that node number is 210. Here first you press save and continue for the now 320 to 210 we need. 320 is there. This 210. Then here is an option for closed loop. See, it's showing this length is coming. Okay. The loop is closed. This modeling of this one means exactly the drawing of whatever the line is given into the caesar.